So in this section, we'll be looking at how to size small solar system for small agri businesses, and we'll look at all the components, the factors we need to consider in sizing the system. Okay, so just for context, currently most farms are in remote areas and use diesel as their source to power pumps and for other power tools. And there's either no access to the grid or grid power supply is unreliable. And being on the PV systems allows for some savings in the region of 20 to 30%. And also having access to the solar power as a sustainable source reduces exposure to price hikes in energy from the grid and national sources. So just to begin this session, reflect on the a system on a farm and just estimate your consideration for how much power is needed on the farm for the pumping and irrigation systems and for refrigeration. And that will be a point of reference for the next exercise. So the first step in sizing, we'll have to look at the power needs of the farm. And for a small farm, assuming just bare minimum, a pump, a fridge, and the lights on the farm. And so just take 5 minutes to fill out this table as a template for computing the total power demand for a small farm. So assume it's your farm and estimate how many hours a day the pump will be running, how many hours a day the refrigerator will be running, and then how many hours um, combined for 10 bulbs, how many hours they will be on. And based on that, you the power, multiply the power by the hours to get the watt hours per day, and then we'll total that to get our total energy. And that is what we'll use to get the sizing for the system. So next we'll size the arrays for the solar panels, and the total rating of the panels in kilowatts is the total energy use by safety factor. In this case, we are using 25%. The peak sun hours, in this case, we are using 4 hours. And then the efficiency of the system as 75%. So the total load by the safety factor divided by the peak sun hours and the system efficiency will give us the sizing of the PV arrays. So based on the figure you got from the previous slide, just input these together and then let's see what we get for the PV size for your particular system. Next, we'll look at sizing the battery and the inverter. Um, so the inverter is a much simpler one. Whatever your peak load you got, you add 20% to size the inverter. For the battery, we are looking at the autonomous days. Autonomous days is if, for example, you have two continuous cloudy days, you want to be able to have power reserve to run for 2 days if there is no sunshine. So your daily capacity, again, the same figure from the previous slide, by the number of autonomous days. Then we divide that by the total depth of discharge of your battery and then the battery voltage, and that gives you the battery capacity you need. All right, so just to wrap up, we should consider also that sometimes in Hamatan there's a lot of dust, and I want you to just think through and consider what kind of effect do you think the dust will have on your solar system, and how that influence how you calculate and size and how you manage a system after it has been installed.
So in this class, you are going to understand the care for solar system and set achievement here. Okay, so solar systems are reliable but require regular care and maintenance for them to be able to last long, work effectively, and then prevent breakdowns. Without these maintenance, the solar system is not going to function effectively. So these components require the solar panels, the inverter, the batteries, the charge controllers, and then the wiring system. Each component requires specific care. These routine maintenance practices include cleaning solar panels, checking wiring and connections, inspecting their physical damage, monitoring system performance. And these must be done weekly or monthly or at regular schedules. There are several equipment for cleaning, like as you can see over here. Cleaning with a soft cloth and then water, allowing harsh chemicals or rough materials not to be deposited on top. They're removing shading objects so that I can have direct access to the sun. Battery maintenance. Now the battery is also important that it needs to be cooled, so it must have a warm exhaustive uh, outline and then low intake vent so that air can go through the battery and then come out uh, well. Then check battery charge regularly, ensure proper ventilation, clean terminals to avoid corrosion, avoid overcharging or deep discharge of the battery. Then for the inverter too, we would need to check the inverter regularly to make sure it's functioning well, as well as check for the connections to avoid any electrical problems. Ensure long-lasting lifespan whenever you do regular maintenance by replacing faulty components, perform regular maintenance, schedule professional servicing, as well as lasting for 20 to 25 years. So yes, whenever you do maintenance of our panels, we ensure efficiency, safety, and then long lasting of our solar panels.
Hello, I will be presenting on learning objective 2 of our project topic solar power as a sustainable energy source for small agribusinesses. And so the objective is to assess how solar helps reduce operational costs in small agribusinesses. And we know agribusinesses rely on energy for irrigation purposes, processing being grinding, drying, and packaging, and also storage with regards to refrigeration and their cold rooms. And this is a picture of a woman trying to preserve her avocado using a solar refrigerator. There's also a picture of a farmer trying to use solar panels to generate water for irrigation purposes. And so the key issue here is that many businesses depend on fuel, either diesel or petrol or unreliable electricity. And so this leads to high and unstable costs. And solar is generated from sunlight using solar panels, inverters, and batteries. And once it's installed, it's only the sunlight that it needs. And some sources of operational costs that are eliminated using solar is the main energy related costs in agri businesses are the fuel costs, electricity bills, generator maintenance, and some equipment that may break down. So we also have solar reduces cost in these following ways: no fuel costs at all, lower electricity bills, low maintenance costs, and long-term savings based on the lifespan of the panel that you're using. So the key message is that solar has high initial cost, but it has lower costs for running. And we have benefits beyond cost, which is solar energy also provides reliable power supply. It also reduces environmental pollution, increases productivity. and helps business with their sustainability. And in summary, we say that energy is a major cost in agribusiness. Solar energy reduces fuel and electricity expense. It also offers long term cost savings and sustainability and improves efficiency and profitability. And in a nutshell, it is cost saving and a sustainable solution for small agribusinesses. And even though it has the disadvantage of an initial cost which is higher, the long term benefit supersedes all the initial costs incurred. And so this is a very valuable procurement decision. Thank you.
Welcome. In this class, we are going to learn about the accounting for solar system purchases and usages. By the end of this session, students should be able to understand solar system, how it's treated as an asset, how to record the purchase of it, how to know the treatment of repairs and maintenance as well as replacement, and understand how solar system affects electricity expense in our book. So what is a solar system in accounting? Accounting, when a company buys a solar system for use in its operations, is treated as a non-current asset. That is because it's purchased for long-term use and it helps the business to operate. It's not meant for resale. So EV is an asset. So suppose a company buys and installs a solar system for 60,000. This will mean that the company is going to debit its solar system asset account with 60,000 and then credit its bank account or cash account with the 60,000, assuming that it was paid off immediately. If the company buys on credit, then there are two forms. It's either it buys it on credit from a supplier or on credit on loan from a bank. If it buys on credit from a supplier, we will debit our solar system asset account, 60,000, and then credit our supplier payable account with 60,000. If it's on a loan, we will create a loan account and then debit the solar system account to 60,000 and then credit the bank loan payable account with the 60,000. Depreciation means dividing the cost of the long-term asset over its useful life. So here we are going to, it's like we are taking a portion of the cost of the asset and then applying it to the revenue that is acquired in the period. So if there is no residual value, then the depreciation charge per year, if you assume a 10-year useful life, is going to be 60,000 divided by 10, giving us a per year rate of 6,000 per year as depreciation in the example we are given. If we are going to pass the depreciation on monthly basis, then this 6,000 will have to be divided by the 12 months. So 6,000 divided by 12 will give us 150. It will give us 5,000 per month, and this will be passed as depreciation in the account by debiting the depreciation expense account by 500 and then crediting the accumulated depreciation by 500 every month. Now in the financial statement, the solar system appears as a non-current asset under the property, plant, and equipment. And then the accumulated depreciation value will also show under the non-current assets, giving us a net book value of the net book value, which is the cost of the asset less the accumulated depreciation. So in our example, if the cost is 60,000, the depreciation for the year is 6,000, then the net book value is 54,000. And this is going to be calculated on yearly basis. So in summary, we've learned that solar system is a fixed asset when you acquire them, capitalized at the total cost of the installation, depreciated over the useful life, and then repairs are expensed over the period whilst major upgrades are capitalized, and it helps reduce our electricity costs. Thank you.
Business. So, as envisaged, the food safety and the quality testing rely solely on the shoulders of the laboratory, and the solar power is important in keeping this objective in full operation. So how does the solar panel help? It helps to provide electricity for testing the machines and the lab devices, as mentioned previously. It also supports the continuous research and analysis that are required for tracking and also to monitor the sustainability of some of the decisions that are being taken in us to see which crop or which product is doing well and then which other is also not doing well. So we can see how best we can actually compete like with the market and also make sure that we have a very sustainable business. Then the impact also improve the also productivity and of course the decision making that is required for the farmers. In terms of the solar, since it becomes a very good opportunity that helps in also maintaining a free flowing power. It helps okay in the processing of the equipment. That's the processing that the equipment takes on to be able to, so that we are able to actually package them very nicely, and also to support the small scale agro businesses, as well as it reduces the energy and the cost and increases the profitability. Okay, where we are able to, have value for money for the products that are on the market, or also for the products that we incur in the business. Of course, there is also the need for export and certification laboratories that actually does the quality assurance. Of course, all these, or to achieve all these, we need a sustainable power supply. So the solar panel is very essential to ensure consistent power supply for the testing and the certification. It also prevents delay and also that have been caused by power outages. And of course, the impact helps to meet international export standards. Then the equipment also requires adequate power supply to prevent any interruption. Another important area is looking at how we are able to reduce operational cost. Electricity is costly, and considering the fact that all these things affect the output of the business, of course, for reliability, the solar panel at all cost, so as to maximize profit and then also increase the output, as well as provide quality